Hello and welcome to our next video lesson dedicated to ZondRes3D software specifically. So out this video lesson I'll tell you about new possibilities and how 3D processing looks like in new vertical. So what is 3D ERT? This is massive problem which needs special computer and sometimes a lot of memory. So you should be prepared to use powerful computer. But here I'm using not so powerful computer. It's just mobile processor, but it has 64 gigabytes and it's enough for let's say medium-sized problem, so I can handle 60 gigabytes in one time, and this is huge. So it's time consuming, of course. Let me show you my processor characteristic. It's 64 gigabytes and let's say mobile processor with 6 cores, so it's not so powerful. And it is without cooling system, so it's reducing frequency on some massive calculation to avoid overheating of processor. So I believe if you use normal desktop computer, it will much faster. So let's start with some problems which I call small size problem. So I will take some examples from Res3D Inf library, and we have a lot of modeling examples and some of field examples. So all this problem is small. Let's see how profiles looks like, and next generation of mesh. Of course, for these synthetic examples, it's very easy to construct mesh. And let me show, this is linear array, and speed of calculation now is pretty fast. So for such examples, it takes seconds per iteration. So it's pretty fast, and progress convergence is shown here. So let me check different types of data set. For example, here is cross-bore hole, and it's combined data set with length measurement and boreholes measurement. And here is 3D pseudo-section. Now I install 2 nodes between electrodes. Of course, it will be a little slow, but for boreholes, sometimes it is necessary. But anyway, it's pretty fast. So, of course, I can use different type of inversion, like robust inversion or common version right here to make model look much pretty. For example, here I can use Now, robust method. It's pseudo L1 norm for data and model. And in this case, you will see kind of blocky structure. Something in this way. So also, of course, they improve speed of interface. So some pre-processing procedures are now working much faster for sorting, for everything, to make work with large and huge models not so slow. Okay, here is another type. This is pseudo 3D model. And here, for example, we added another type for topography interpolation. It's much faster. This project contains a lot of measurements, but not so many model cells, so you can check it here. Here is a records number and model parameters number. Here is how much memory is necessary for forward problem and for inverse problem, and how much memory is available. So you also can check it here, and if it's not enough memory, you can use this cell grouping dialog for reducing of memory requirements for inverse problem. So it's calculated because it's pseudo 3D, all data set splitted to independent part, and it's maybe a little slowly, but it's much better for memory economy. So we can use more memory for inverse problem and more cells in this case. Now, unfortunately, most of calculation time sometimes take calculation of system, final system, because it's huge system like 25 gigabytes, and this big matrix should be multiplied to vector many times, and of course it's taken time. And even for this example, it's maybe takes 6 minutes per 10 iterations, so it's pretty fast. Okay. You can use different type of 3D view, different transparency profile uh, to see some targets inside. We can use different type of contours or blocky models with using settings of Alexia. Okay, now we will take another example from Dr. Loki Legacy, and it suggests me use specified grids profile, but I'll not. Just show you how to use such type of survey. You just use general, and for example, it's a pretty good mesh. Maybe it's too much nodes, but anyway, as you can check if everything all right. Everything all right means that two electrodes, potential and current, not in one cell. Here is not. Oh, let's me use another. And here is how model looks like. This is our model. And something topography effect, because it's not so many points for topography. It's maybe not super interpolated. Okay, here is not so many points. You can see this is very old survey, not so dense. I just show you that you can use software for different type of survey, not necessary all should be regular. As you see here, the different angles between uh, lines. I think it's also pseudo 3D. Speed now is much slower because this model is much bigger. It's a lot of cells, but anyway, it's not so slow as in previous versions. Here I'm not using any optimization like L-curve or just simple optimization of smoothing factor, because it will take more time, really 6-7 times more, and I think it's It's no good for this presentation, but you can use this option on your computer. Okay, here is result 1.5 iteration. Usually it's enough 10 iteration for any survey. It's just very unexpected situation when you need more. In most cases, I need 5-6 iteration for to achieve very good level of misfit. Of course, if it's possible, because sometimes the data is very noisy, and it's never happened if you even use 100 iterations. Well, I'll stop it and go to another example. So I think this is this one last I would like to show you from this collection. It's always shows some messages about wrong topography, and indeed sometimes it's correct because it's finds some very rough relief points, topographic points, and trying to smooth it because sometimes it's impossible if we work with cable and we have a constant distance. It couldn't be difference in elevation more than distance between electrodes. So it's sometimes correct, sometimes it's just a warning. Okay, this is another data set, ZondRes3D. Let me use also example this topography. Here is maybe a very long side on of one direction. So maybe here is better to use wall model inversion. This means not only inversion inside this 3D cube, but also outside will be inverted cell. Sometimes it gives a good results if we use these options. It's a little slowly, but we don't need restriction on 1D in these areas. So here we will not see what exactly in these areas, but if we have some targets or anomaly on the side of this box, it will work much better. Also, we suggest two types of solvers. Direct one, which you can use for most of cases. But if you have a very several lines for very big model, so for example, very sparse system, iterative solver can be better for this case, and it not use so much memory. Plus, you don't need to do some massive calculation on every iteration. Okay, I think it's enough for this. Of course, we have different type of visualization. Different levels. Okay, now we're going to my examples, and here is interesting type of surveying. I actually don't like this type of surveying, but sometimes uh, things happen. This is how uh, cable looks like, and this looks pretty strange. Here is no topography. Let's use regular type of mesh, and here is a lot of data. Yeah. So it's much more that it's necessary. Not okay. Let's see how many points for this sparse survey. Huh? This is 40,000 versus 50,000 cells. Let's make less cells because resolution fall very quick with depth. We don't need so small cells for inversion. Here is just it's not pseudo 3D, so all cables connected to all to others, so it's just one piece of data and it's not splitted, so no memory economy in this case. So everything calculated pretty fast, and only this huge system, final system, is take biggest part of inversion, because let me check. This is almost 9 gigabytes. It's not so big, but in comparison with the previous examples, it's already more, because Ikeboard example took 4 gigabytes and it takes 6-7 minutes per 10 iteration, and this one maybe more, plus we use double boundary conditions, so much more cells from left, right side, and as I think here is options for wall model. This means it's even more parameters cells than we seen in this status string, because it's added about 12 elements from every side of this box. Anyway, it took maybe 1 minute per iteration. It's not so long, and for good desktop computer, it may be twice better. Because for mobile processors, as I said, it's reduced frequency during calculation to avoid overheating of processor. One trick I'll show you, but now, if you want to stop software from calculation, you can do it here, but sometimes you need to wait until some process is finished. But you can use also Task Manager, and I'll show you on the next example. Without killing software, you can just kill calculation process. Okay, let's see what else we can do. For example, this is example of resistivity and IP, and all our joint inversion, not all of course, but some set of joint inversion should work. So I'll show you. So you can invert resistivity and IP separately. This is okay. Also, you can use joint operation to make your models be in one geometry and has a better similarity, better correlation. For example, I'll go to cross gradient, choose IP. If you want to save memory, you can use reduced IP, but it's not so good because IP data also depends on resistivity, so it will be a kind of approximation. And I can use criteria, and for example, it's common correlation criteria, like in 2D software. There is not so many electrodes. And let me do, okay, joint inversion. Let's calculate two problems together, resistivity and IP, so it's twice longer. But anyway, if you inverted it separately, you need to make two inversions. So it's practically the same time. Here is pseudo 3D, so it's split into 14 different lines because they are not connected. There is no connection of electrodes, throws, and measurements. And yes, it's allowed to save a lot of memory. Let's make free calculation, free iteration, and I'll stop inversion in way I will show you. Because sometimes if you work this very big set, this is every step is very small and you couldn't kill calculation process immediately. So let's wait a little. Three iteration, or maybe four iteration for this criteria to have a good correlation. And last one. Because it's already goes to asymptote. No super big change after four iteration, I expect. Okay. And here, for example, we have our library and we just can kill it. And process of calculation immediately stopped. So we have a resistivity model and polarizability, chargeability. So it has a pretty good correlation. Of course, it will have a better correlation if we use 10 iteration. But for example, let's see how metal factor looks like. Yes, here is this low resistivity and high chargeability effect. And we can judge about some maybe ore deposit right in here. It's 2D, I suppose. Well, here is area with volume as maximum probability on this. So this is how this type of inversion looks like. I mean, joint inversion. Let's back to normal. Let me show you another example. You can invert this software if you have enough memory. This is huge example, and this inversion took about 6-7 hours per 10 iteration. Of course, it's a lot of cell grouping used because I have not enough memory on this computer to handle a full program, so I group some lower cells and big groups. And here is how 3D pseudo-section looks like. Yeah, so it's calculated without problem. Here is another part of data set with IP, and it also has very good misfits. But of course, my recommendation to have a lot of memory on your computer, minimum 100 gigabits for such examples, or even more, it will be better. So thank you very much. I hope you like my presentation and see you next video lessons. Bye bye.